Hi everyone, my name is Geoffrey Ong Chun Ho. My Matrix number is 2211711779, and I'm from the course UR 6524002 Polymer Engineering. Today I'm going to make a presentation for my engineering quality control assignment. In this presentation, there will be a 6 section including introduction, control charts, process capability charts, ANOVA, comparison, and conclusion. At first, I would like to introduce R software. R software is a programming language and free software environment primarily used for statistical computing and graphics. R software is a powerful tool for everyone working with data, providing flexibility and a rich set of features for statistical analysis and visualization. Next, responsible consumption and production is a sustainable development goal focused on minimizing waste and promoting the efficient use of resources throughout the manufacturing process. In this assignment, we are given a dataset containing data from 3 machines with factors such as timestamp, temperature, pressure, part length, and part pressure. Let's discuss about the control chart for 3 machines. Control chart is a statistical tool used to monitor or analyze processes or data over time. It helps identify variations within a process, distinguish between common causes variation, inherent to the process, and special cause variation due to external factors, and determine if a process is in control or out of control. Control charts are widely used in manufacturing, healthcare, finance, and other industries where process consistency and quality are critical. They are essential tools for quality management and continuous improvement efforts. For machine 1, under the condition temperature is equals to 338 Kelvin, pressure is equal to 200 kilopascal, we can see that all the subgroups value fall between upper control limit and lower control limits, and there is no outlier present, therefore the process is in control. Next, under the same condition is shown by the control chart for machine 2. The process is out of control because there are 2 points beyond the control limit. The point A is beyond the upper control limit and the point B is beyond the lower control limit. The control chart for machine 3 under the same condition show that the process is out of control because there are only 1 point beyond the control limit, whereas the point C is beyond the lower control limit. Next, we are going to talk about the process capability chart. Process capability is a measure of the ability of a process to consistently produce output within specified limit. It assesses the inherent variable of a process relative to its design or specification limits and helps determine whether a process meets customer requirements. Process capability analysis is crucial in industries such as manufacturing, healthcare, automotive, and aerospace, where precision and consistency are critical. It helps organizations to achieve and maintain high level of quality and reliability in their products and services. By referring to the process capability chart for machine 1, the mean is equals to 48.21414 and the standard deviation is equals to 1.206965. The process capability index CP value for machine 1 is equals to 1.38, which is greater than 1.33, and the CPK value is equals to 0.888, which is smaller than 1. Since the CPK value is less than 1, it shows that the machine is not capable. Moving on to the machine 2, the mean is equals to 49.12882 and the standard deviation is equals to 1.097566. The CP value shows 1.52, which is greater than 1.33, and the CPK value is equals to 1.25, which is greater than 1. So since the CPK value is greater than 1, the machine shows capable. Next, we are looking into machine 3. The mean is equals to 48.11748 and the standard deviation is equals to 0.6880963. The CP value for machine 3 is equals to 2.42, which is greater than 1.33, and the CPK value is equals to 1.51, which is greater than 1. So since the CPK value is greater than 1, the machine is capable. Now we are going to talk about the analysis of variance, ANOVA. So analysis of variance or ANOVA is a statistical method used to analyze the difference among group means in a sample. It tests the null hypothesis that means of several groups are equals against the alternative hypothesis that at least one group mean is different. ANOVA provides a robust framework for analyzing data involving multiple groups or treatment, allowing for rigorous statistical inference and informed decision-making based on group differences. For machine 1, we can see that the PR greater than F value for the pressure is equal to 0, which is smaller than 0.05. Same goes to the PR greater than F value for temperature is also equal to 0, which is smaller than 0.05. And the PR greater than F value for pressure times temperature is equal to 0.0718, which is greater than 0.05. So for machine 1 resistance, the factor P and factor T are significant. However, the factor P times T is not significant for machine 1. Moving on to machine 2, the PR greater than F value for pressure and temperature is equal to 0, which is smaller than 0.05, where the PR greater than F value for pressure times temperature is equal to 0.678, which is greater than 0.05. So the factor P and T are significant for machine 2, where the factor P times T is not significant for machine 2. Next, for machine 3, the PR greater than F value for pressure and temperature is equal to 0 also, which is smaller than 0.05, and the PR greater than F value for pressure times temperature is equal to 0.622, which is greater than 0.05. It shows that the factor P and factor T are significant for machine 3 resistance. However, the factor P times T is not significant for machine 3. So these are the box plot for all machines. This box plot are showing the part resistance of the machine versus the temperature of the machine. So next we are moving into the comparisons. We are going to compare the three machines based on the data we analyzed before. From previous we've seen the machine 1 process is in control. The CP value is equal to 1.38, which is greater than 1.33. The CPK value is equal to 0.0888, which is smaller than 1. The factor P and factor T are significant for machine 1 resistance, but the factor P times T is not significant for machine 1. Where the machine 2 and machine 3, both machines processes are out of control. For machine 2, the CP value is equals to 1.52, which is greater than 1.33. The CPK value is equals to 1.25, which is greater than 1. The factor P and factor T in machine 2 is significant. However, the factor P times T is not significant for machine 2. In machine 3, the CP value is equals to 2.42, which is greater than 1.33. The CPK value is equals to 1.51, which is greater than 1. So for machine 3 resistance, the factor P and factor T are significant. However, the factor P times T is not significant for machine 3. In conclusions, after reviewing all the charts in the assignment, the conclusion that I make is no machine is recommended. The reasons none of the machine in this assignment is recommended is that each machine has its own significant disadvantages. Machine 1 has a control process, but the CPK value is less than 1, which indicates that despite the process is being in control, it lacks actual capability due to the process is not being centered within the specification limits. This means that machine 1, while stable, may produce output that do not consistently meet quality standards. On the other hand, machine 2 and machine 3, although demonstrating high capability indexes with CP and CPK value exceeding the acceptable threshold, suffer from processes that are currently out of control. This lack of control leads to variability and inconsistency in production, making them unreliable choices despite their potential for high quality. Consequently, the instability of machine 2 and machine 3 combined with the insufficient centering of machine 1 leads to the conclusion that none of the machines are suitable for recommendation at this time without further improvement and stabilization efforts. It is essential to address the centering issue in machine 1 and brings the processes of machine 2 and machine 3 under control to ensure consistent and high quality production. That's all for my presentation today. Thank you.